So today's lesson is a follow-up about vectors. We're going to be finding the components of a vector. Whereas previously we took two perpendicular vectors and we found the resultant vector. And it looked a lot like this. And we did Pythagorean theorem and trig to figure out what direction and how much this was. That wasn't really that bad, just we kind of brushed up on our trig skills a little bit, and geometry skills. This time we're going to go back the other way. This time we're going to start with a vector and then figure out the x and the y components of the vector. Now, when I say components of a vector, any vector can be broken up into a horizontal component and a vertical component. Just like you see that when we have a horizontal and vertical vector, we can make it into a non-horizontal, non-vertical vector. We can go backwards too. So if this is v, we could call this vx, and we could call this vy. We have velocity in the x direction and velocity in the y direction. And we'll learn later when we get into two-dimensional motion that those two velocities are actually independent. So how do we do this? It's really just basic geometry. Let's say that we have a grid and we've got a vector that is 7 meters per second at 35 degrees. And we want the x and the y components of that vector. We want this and we want this. Okay, so we want vx and we want vy. How can we figure it? Well, it's just trig. We know this angle. Vx is the adjacent side. We know the hypotenuse of the right triangle because the components are perpendicular. So we just do some trig. So adjacent hypotenuse, that's cosine. So we'll say cosine of 35 equals adjacent, which we don't know, over hypotenuse, which is 7. So solving this, we get the adjacent side equals 7 cosine of 35, which we can do here, times 7. So we get that the x component is about 5.73 meters per second. And to get the y component, we do a similar thing. This time we're looking for opposite. So this is going to be sine. So sine of 35 is going to be equal opposite over hypotenuse over 7. So opposite equals 7 sine of 35. Pretty simple. So we get about 4.02, call it. So the equivalent horizontal velocity is 5.73. The equivalent vertical velocity is 4.02. It's basic trig. This is right triangle trigonometry. You should have seen it before. Alright? Now I'm pretty much expecting that anything in quadrant 1 is not going to give you much trouble. So let's do something that's not in quadrant 1. Alright, let's put our vector this time down here. Here's my vector. Alright, and we're going to want the x and the y components of this vector. So the x component is going to look like this, and the y component is going to look like this. Alright, we need to give our vector some information. Let's say it's negative 20 degrees, or excuse me, it's not negative 20. Say that that angle is 20 degrees, and maybe the magnitude is 10 meters. This is a displacement vector. Alright, so we want x and we want y with the x and the y components. Since this is a displacement, we can just use x and y because that's what we usually do. Okay, so let's find x first. So this is adjacent. We know hypotenuse. So again, cosine of 20 equals adjacent over hypotenuse, which in this case is 10. So it's going to be 10 cosine of 20, which is 9.4. 9.40 meters. Alright, and then we need the opposite, which works exactly the same way. So now we're doing sine, so sine of 20 equals O over 10, so O equals 10 sine of 20. So about 3.42. Now, notice that this vector is pointing straight down. Down means negative. You just have to notice that. It should be obvious. If we had a vector this way, we kind of talked about this last time, it would also be negative. So let's do one like that. This will probably be the last example of this. This is pretty easy stuff. So here's a grid. We'll have a vector over here. We'll give it 15 degrees, and it's 2 newtons. And we want the components. Okay, well, to find the x component, again, cosine to find x. Cosine of 15 equals adjacent over hypotenuse, so I left out the 15. You get the idea. So adjacent is 2 cosine of 15, and hopefully by now we're comfortable that opposite is 2 sine of 15 without working all of that out. So let's figure those real quick. Oops. So the x component, this would be Fx. This is force in newtons, which we haven't done force yet. That was 1.93, and Fy is going to be sine .52. These are both in newtons. Okay? Except that the x component is in the negative direction, so this should be a negative force. That's a subtle thing, but it matters. Positive and negative forces, distances, velocities matter. So that's it. You'll have a few problems on this, but I hope you all agree that this is pretty easy.